Okay, it's problematic. I do want to point out the function they're giving at 11 is certainly continuous in that interval between 0 and 2 pi. There's no troubles at all because sine x plus 4 is non-zero. It's always positive, all right? So what do? I write the derivative down. As I do it, though, I'm going to rewrite y. We'll check it one step at a time. It's 3 times the sine of x plus 4 to the minus 1. So I'm going to write down y prime is going to be minus 3 sine of x plus 4 to the minus 2 times the cosine of x. I'm going to clean it up. I'm going to say y prime is minus 3 cosine of x over sine of x plus 4. That whole thing is being squared. So I want to go to the key and look at it and make sure I got that written down for you. And this is really what you should be doing when you're taking an exam when you're doing homework, is looking at the key and saying, gee, I met that milestone. The next milestone I want to do is I want to see what are the critical values on the interval between 0 and 2 pi. So looking at the bottom, I'm not worried about because the bottom's always positive. It's never 0. But the top becomes 0 at pi over 2 and at 3 pi over 2. And then I'm going to take test points here. I'm going to list degrees because it's easier for most people to speak that language. Between 0 and pi over 2 is like between 0 degrees and 90 degrees. I don't know, I can say 45 degrees. Over here, between pi over 2 and 3 pi over 2, I'm going to say pi or 180 degrees. Over here, I'm going to simply say 300 degrees, right? Relatively simple numbers, easy to compute with. And by the way, when I say compute, I'm not even talking about the numbers, I'm talking about their signs. So if you look at the signs of these things, the bottom's always positive, and looking at the top, cosine of 45 degrees is positive, negative times a positive is negative. What do you get for 180? Well, the cosine of 180 is a negative number, and minus 3 times a negative number is a positive number. Then if the cosine of 300 degrees is a positive number, a negative times a positive is a negative number. So I have my points of inflection now. And I'm sorry, not points of inflection, but my local extrema. So I have a minimum at x equals pi over 2. Again, the function's decreasing, increasing, that's a minimum. What do we have over here? Whoops, sorry about that. I have it increasing here. I'm sorry, I did that again. Decreasing over here. So I get a maximum at x equals 3 pi over 2. Let's just look at the k. And again, we already checked the derivative. The critical values, we got those listed over here. Relatively simple. Local maximum. I spelled max wrong. Local maximum at 3 pi over 2. And a local minimum at pi over 2. So we're off to a good start. All right, so what do you do next? They ask for another thing. They ask for the points of inflection. Let me get my eraser out. I'm done with A. I feel comfortable about A. As you go up in derivatives, though, they're going to get more difficult, right? So what I want to do, I want to do the second derivative. Someone says, how do you do that? I got to get the first derivative. Well, we just did that. I'm not going to redo that, but I do want to write the second derivative down for you. So y double prime. I might need more room for this, so I'm going to back up. Y double prime. A long bar down, square the bottom. Again, we're taking this guy's derivative over there. That's going to be sine x plus 4. That thing is going to be being squared. That means fourth power. Bring the bottom to the top. And leave them alone. Times the derivative of the top. And what's that going to give me? That's going to give me 3 sine x. Minus the top. Well, minus and minus is plus. Times the derivative of the bottom. That's going to be 2. This looks awful, doesn't it? Sine x plus 4 to the first power. And derivative of the inside is going to be cosine x. And it looks really kind of difficult. As I go through it though, I want to emphasize, I'm looking for something easy to do. And before I do anything, I notice that there's a lot of these factors around. And what I'm going to do is I'm going to divide one of them away. So write this over here, y double prime. I'm going to divide one of them away. So I'm dividing the top by sin x plus 4 and the bottom by sin x plus 4. What do you get in the bottom? You get sine x plus 4 cubed. What do you get on top? And again, it does take some time and effort to do this. Well, if I divided one of the factors away, there's two factors, I get one of them, and then you get 3 sine x here. Plus, well, I'm looking at this is 6 cosine squared. All right, where am I getting it from? This is 6 cosine, there's a cosine there, 6 cosine squared, and I'm dividing that away, so it's gone. All right, it's not 0, it's never gonna be 0, it's always positive, I'm not too worried about that. I got another problem here. I'm looking at this, just looks crazy to me, so I'm gonna keep rewriting it. And what's nice about having a key, you have something at least to look at after you finish what you think is the right derivative. And let's take a look at that. You get 3 sine squared x. Let's see if I did that right. Yeah, plus 12 sine x. And going back to my pre-calculus days, trigonometry, I realized I want everything in terms of sines. So I'm going to say this is 6, and cosine squared is 1 minus sine squared. So it's going to be plus 6 minus 6 sine squared x. Well, let me keep looking at this thing and see if I can, maybe figure that out. And I'll write it down. And what do you get there? Minus 3 sine squared x plus 12 sine x plus 6 over sine x plus 4 cubed. I'm still not there yet, because the reason I wanted to see if I can, maybe pull something out from that. And I'm going to pull out a minus 3. And once I do this, I think I'm at a place where I'm going to look at the key. And you're going to get sine squared. Let's see, plus, not plus, minus, right? Minus 4 sine x. So you get minus 3 sine squared. That's good. You get plus 12. And then what do you get over here? Looks like minus 2. All right? Now, before I go on, I just want to look at the k. I'm looking at this part here, and I got this one over here. That's a cube, by the way. I noticed that they put a 3, and I put a minus 3, so I factor out the minus 1. So I'm going to say, yeah, I got it. It's sine squared, minus 4 sine. Yeah, that's pretty good, all right? So I'm going to say, what are you going to do now? Well, there's trouble over here, and the trouble over here is that I got to figure out when the by the way, the bottom is not my trouble, it's the top is my trouble. And I'm looking at it, and I'm kind of wondering what's going on there. So I'm going to, write this down a little bit differently because it looks really strange to me. I'm going to write it as minus 3. Now I'm going to make a substitution. I'm going to say u is sine of x. That's what I'm going to say. All right, so what do I do over here? This would be u squared minus 4u minus 2. Now I'm going to say I don't think that factors u. By the way, that's the top, by the way. That doesn't factor nicely. So I'm going to use quadratic formula. I'm looking at the top, by the way. We'll get back to that in a moment. U equals twice the a, the coefficient is 1. Opposite of the b, 4, plus or minus the b squared, which is 16, minus 4, times the a, which is 1, and times the c, which is going to be minus 2. So it's going to be plus 8. All right? What do you get? U is 4 plus or minus a terrible number. 16 and 8 is 24. over 2. And yep, it's a tough one. So what do you get here? U 4 plus or minus. Well, I hope you realize that 4 times 6 is 24, and the square root of 4 is 2. So 2 root 6. What do you get in bottom 2? So U is 2 plus or minus the root of 6. Well, use two different numbers. It could be 2 plus root 6. That's not a bad number, right? And what's the other number could be? It could be U equals 2 minus root 6. By the way, this one here, I hope you realize, is definitely bigger than 1. And what do I know about that? Well, that the U is sine x, there's no solution to that one. Let's just talk about this over here. All right? Which is a little bit more difficult to deal with, right? So what are you doing over there? Let's take a look. And it's going to be 2 minus the root of 6. And boy, is that troublesome. All right, 2 minus the root of 6. I'm looking at that, and the root of 6, it's a terrible number. It really is. It isn't like working out like this is a pre-calculus question. You have a really nice looking number over here. And by the way, I don't mind using calculators. I don't. But 2 minus root 6, you know, the sign could be that, right over here. Sine of x. It could be 2 minus the root of 6. All right? Now someone says, I wonder what 2 minus root 6 is. Well, I hope you realize it's going to be a negative number. Right? It's a negative number. And then someone says, well, that's really tough to think about. So what I want to do is talk about, I know it's a negative number, and regardless of what I know exactly what that number is, it's not that important to me. But you can get a curve that looks like this over here. And again, I don't mind you using calculators. I don't. But you get a curve over here, and 2 minus root 6, well, the root of 6 is certainly bigger than 2. That's going to be a negative number. So I'm going to say it hits it twice, here and here. All right? So what I want to do is I want to talk about the reference angle. I'm going to say theta reference. What's that going to be? Arc sine. Well, I'm going to write something down that you might get confused by, but root 6 minus 2. So really I'm taking the positive numbers. I'm going to get a nice cute angle there. All right? But then I got to start thinking, what are the angles? What's x then? So the first x, and this makes it tough, is going to be between, this would be pi, and this would be 3 pi over 2. So I got to really take pi and add the reference to it, and that's going to be arc sine. And again, I don't mind using calculators on something like this, and you probably should learn how to use a computer to do this anyway. What's the other one going to be? X equals, well, that's going to be 3 pi minus the arc sine. Whoops. Okay, what I want to do is go to the key. And as I go through the key, I realized someone says, what are you doing over here? I'm looking at it, and let's just read what they got. So it looks over here, it says, the analysis of this particular problem may be beyond some students' ability. You know what? I think it is. All right, even with the pre-calculus that we have here at Essex, it might be beyond your ability. It does require that you really know pre-calculus well enough to deal with non-trivial problems. The point of inflection occurs at, all right? Now, someone's going to say, what happened over here? And I got to look at it. The point of inflection, determine the point of inflection, concave up, concave down. Actually, I have to correct my notes too because I didn't write them both down. And there's actually another one. And I didn't write that down for some. Yes, it does require that you really know pre-calculus. The point of inflection occurs here. I'll probably post a video of this. By the way, the other point of inflection occurs at, let me see if I at least wrote that down correctly. Well, they wrote a little bit differently. I'm going to update the notes to reflect this, by the way. And by the way, I'll also post a video. Right? I will post a video of this over here and go backwards. I'm going to correct my notes and point out the points of inflection occur over here. I wonder why that happened, but I'll go over it. Don't worry, I'll post a video, all right? So what I'm going to post a video of, I'll certainly graph it out for you, and I'll point out that points of inflections do occur here and here, right? And I'll also point out the intervals of concavity for you. And I will update the notes, by the way, so they reflect correctly. Thank you.